Hello guys, welcome back to this channel. On today's video we will see how to determine the design moment for a square slab using yield line analysis. For similar problems and videos, check out my channel. So stay tuned. Suppose you have a square slab which is simply supported on all sides and subjected to a uniformly distributed load W. It has a length of L and a width of alpha L. For a square slab, L is equals to alpha L. So the first step will be to determine the yield line pattern. Notice that yield lines originate from intersection of axis of rotations. So these four red crosses indicates the intersections of axis of rotations, and yield lines emanate from these intersections. So we have a series of yield lines originating from the axis of rotations. Once all the yield lines meet at the center of the slab will fail. Upon failure, the slab shows some type of triangular deflection pattern, and we have to determine the internal energy, then determine the external energy, and compare those two to determine the moment. So internal energy is equals to external energy. Internal energy is equals to the product of moment multiplied by rotation multiplied by the length of the projected yield line. And external energy is given by area times load times the average moved distance for each right half slab. So the first task is to determine rotation. Similarly, as in the case of rectangular slab, we will take this right angle triangle and determine this rotation angle phi. So this delta indicates the maximum deflection which occurs at the middle of the slab. So using trigonometry, tan phi over 2 will be delta over L over 2. But for small rotation angle phi, tan phi over 2 will be equals to phi over 2. And phi over 2 is equals to delta over L over 2. Solving for phi is equals to 4 delta over L. So we have found the rotation. Next task is to determine the length of the projected yield line. So this zigzag dot line indicates the yield line, and we want the length of the projected yield line. So the projection of this yield line onto the axis of rotation indicated by the solid red line. So the projected yield line length will be alpha L. So internal energy is equals to moment multiplied by 4 delta over L multiplied by alpha L. But this slab fails in two directions, hence this must be multiplied by 2 to obtain the total internal energy. So the total internal energy will be 8 m alpha delta. Proceeding, we will calculate the external energy. External energy is given by area times load times the average moved distance. So the average moved distance in the case of triangular yield line pattern is delta over 3. So each one of these four regions contribute a deflection of delta over 3. In case of rectangular regions, the average moved distance was delta over 2. But in the case of a square slab, the average moved distance will be delta over 3. So what we do is we will determine the area, the load, and the average moved distance for a single triangular region and multiply that by a 4, since we have 4 regions, since the yield line divided the slab into 4 regions. So if we take this region, the area will be alpha L multiplied by L over 2. So L over 2 multiplied by 1 over 2. So half base times height multiplied by the load W, and the average move distance for a single triangular region is delta over 3. Since we have 4 regions, we will multiply this by 4 to obtain the total external energy. So the total external energy will be WL square alpha delta over 3. To determine the moment, we will equate internal energy to that of external energy. Alpha will cancel alpha, delta will cancel delta, and we are left with moment is equals to WL squared over 24. So the failure moment will be WL squared over 24. So that's it, guys. Thanks for watching. If you find this video helpful, don't forget to subscribe to support this channel. Thanks, guys.